Hello guys, I am Parinita Hajra and I welcome all of you to Online Study for You. So in today's video, we are going to see some of the most important and commonly asked questions for DBMS. So in our previous videos, we have already seen some of the very important questions that can be asked in interviews. Like we have discussed important HR questions like where do you see yourself after 5 years? Why should I hire you? What are your strengths? What are your weaknesses? Right? We have already seen how to answer those questions. And in one more video, we have already discussed about what are the important questions that are frequently asked in interviews regarding C language. Fine, so we have already seen those important concepts in our previous videos. Now in this video, we are going to discuss about most commonly asked DBMS questions for interviews. So we all know database management system is one of the most important concepts or topics that the interviewers are asking questions about. So in this video, we are going to see or we will try to cover almost all the important concepts that are being given more weightage on the interview regarding DBMS. Fine. So let's start. First of all, the most common question that can come in our mind is what is DBMS used for? So what is DBMS used for or why is DBMS needed? So the answer can be DBMS is commonly known as Database Management System. It is an application system whose main purpose revolves around the data. Fine. So what is DBMS? DBMS stands for Database Management System and it is an application system whose main purpose revolves around the data. This is a system that allows its user to store the data, define it, retrieve it and update the information about the data inside the database. So in short, you can explain it something like database is nothing but the collection of data. We all know that in any big applications, if we talk about any big application, any big website, the core part is our data, right? We are mostly dealing about the data, and whenever we want to deal with the data, obviously we want some important storage when we can store our data, from where we can retrieve the data whenever necessary. So this storage or this collection of data can be said as database, and database management system is all about managing that storage of data. Fine. So you can answer it something like that, and this is the figure that explains it very well. That first of all, the database can be anything. Database can contain any number of tables, like as shown here in the left side. It can have the records of students, records of employees. Fine. So one database can have many tables for many different purposes. Now those tables are managed by database management system. Different database management systems can be MySQL, PostgreSQL, Oracle. These are different database management systems which are basically used to manage our data that are present in our database management system. Fine. So these are our DBMS, database management system, that is MySQL, Oracle, etc. And basically we can retrieve our data or we can insert the data, select the data based on the code that we are actually writing inside our program. Fine. So this is the flow that you can explain, that our database is there that contains our data. To manage the data, by managing the data, I mean retrieval of data, updating the data, deleting any old data. Those things are done on the database by using database management system like MySQL, Oracle, etc. And these queries can be written inside our main program or inside our main code. Fine. So this flow you can explain so that it will by this kind of flow diagram, you can use pen and paper also, you can explain it with the help of flow diagram. This will show that yes, the concept is very much clear inside your mind. Question that can be asked is, why is the use of DBMS recommended? Explain its advantage. So yes, we do use DBMS, but what is the need? Why we are using DBMS? So this question can be asked and you can answer this question by stating the points like control redundancy, data sharing, backup and recovery facility, enforcement of integrity constraints. So you can state these points. Now what these points mean? First of all, control redundancy. So this DBMS is helping us to control redundancy. What do we mean by redundancy? Duplicacy of data. So DBMS allows us to manage the data very well. So if we want our database to contain only unique data, we can put that constraint and we can have that. So redundancy or one data is stored multiple times, such kind of problems are not taking place in case of DBMS, because in DBMS the database management systems are allowing us to put up our data in the database in a very organized manner, such that no duplicacy or no redundancy will be there. Fine. So controlled redundancy is one of the points. Second point is data sharing. So sharing of data among multiple users simultaneously can also be done in DBMS. So what happens that, for example, let's say we are having the table of student. So the table of student or the data of student can be used by let's say the class teacher to maintain the attendance report. It can be used by other subject teachers to uh, in order to make the result, in order to make the mark sheets of the students. Fine. So what happens that the same data of the student can be shared among different faculties for different operations. So yes, database management system is allowing us to do data sharing efficiently. Then we are having backup and recovery facility. So DBMS minimizes the pain of creating the backup of data again and again. So this is one of the main problem that takes place in many operations, that data is not the backup of data is not maintained. But in case of DBMS, the data backup is maintained, because it is providing us a feature of backup and recovery, which what it is doing, it is automatically creating the data backup and restoring the data whenever required. Fine. So this is again backup and recovery facilities, one of the important facilities that are provided by DBMS. Then we are having enforcement of integrity constraints. Now what do this mean? Integrity constraints are very important to be enforced on the data, so that the refined data after putting some constraints are stored in the database, and that is followed by DBMS. So obviously we do have some constraints, so we can apply that constraints in the very first place in the data, so that all the data with all the data which data are applying those constraints, who are fulfilling those constraints, only those refined data can be entered on our database. So this also helps us to maintain quality of data. It is allowing us to maintain the quality of the data and the efficiency of the data to be stored inside the DBMS. Fine. So enforcement of integrity constraints is also allowed in case of DBMS. So these are some of the important features that is provided by DBMS, and so DBMS is recommended to be applied on the database. Fine. So this can be your answer. Then the next question can be, what are the advantages of DBMS over traditional file-based systems? So as we know, normal traditional file-based system was already there, in which normal you can create a table or like Excel sheet kind of thing, and you can store your data there. But even though that was there, why this DBMS came into the existence, and what is actually the advantages of DBMS? So it can be answered like, DBMS were developed to handle the following difficulties of typical file processing systems supported by conventional operating system. And so what are the main advantages that are provided by DBMS? As we already discussed some of them in our previous question: data redundancy and inconsistency, difficulty in accessing data. Normally in file processing system, these were some of the problems that were overcome by DBMS. So in normal file processing systems, we were having difficulty in accessing data. Fine, it was not that much easier to access the data by applying filters and everything. But in DBMS, we can easily do that. For example, out of all, for example, you are having the contact list of all the people all over India. So if you want to filter and get only those people who belong to Gujarat or who live in Gujarat, you can simply write the query with the where clause, that where state equal to Gujarat. So that will make your task very easy. But in case of file processing systems, those things were not there. So we were having difficulty in accessing the data. And then data isolation, integrity problems, atomicity of updates, concurrent access by multiple users, security problems. So these are some of the problems that were existing in case of file processing system. But due to DBMS, nowadays due to DBMS, these problems are no more there. For example, if we talk about this last point, there is security problems. In file processing system, obviously there was no such security. But if we talk about database management system, it is allowing us to give access control also. So we can give access control accordingly, so that only the authorized persons can have the access over our database and over our data. Fine. So these things are actually very important. And these are the advantages of DBMS. And then what is RDBMS? So we all know that DBMS is database management system. Now what is RDBMS? It is relational database management system. It is used to maintain the data records and indices in the table. RDBMS is the form of DBMS which uses the structure to identify and access data concerning the other piece of data in the database. So see, if I broadly say you, there are mainly two types of DBMS, that is RDBMS, Relational Database Management System, and Non-Relational DBMS. Now what is the main difference between this relational and non-relational database? Mostly in relational database system, it is allowing us to store the text files, the text data efficiently, like recording the student data, college data, university data. So whenever we are having data in the form of only text, it can be done very easily. It can be stored in the form of tables in RDBMS. But if we talk about non-relational database management system, they are more used whenever we want to store various kinds of data, like media files. Whenever we want to store audio, video, image kind of thing, we can store them very easily in non-relational database management system. So this is the main difference you can consider between these two. Now if we talk about RDBMS, as I told, in RDBMS we are storing the data in the form of table. So in the table the data is there. So in the table we can easily do the operations like inserting the data, updating the data, deleting, changing the data, etc. And most of the time in RDBMS, in order to deal with our data, we are using SQL. We all know what is SQL, Structured Query Language, because it is easily understandable and it is most commonly used nowadays in almost every field. So RDBMS is the relational database management system in which we are storing the data in the form of table, and in order to deal with the data we are using the language that is SQL, Structured Query Language. Fine. You all must be knowing the queries like insert query, select star from database, update from table name, whatever is there. All these queries are actually the queries of SQL that are helpful for dealing with the database or for dealing with the data of the database that are stored, fine, in the form of tables, so in RDBMS. So in this way you can understand that all these things are relatable. Fine. Okay. Now how many types of database languages are there? Now if we talk about database languages, there are mainly, see, there are 4 types as you can see here, but out of them also 3 are main, that is DDL, DML and DCL, but we are having one more type also, that is TCL. So the 4 types of database languages are data definition language, data manipulation language, data control language, and TCL stands for transaction control language. So first of all, if we talk about data definition language, what are they? So all the queries or the commands that are mainly used to directly deal with database, that are used to deal with the tables and the database, they are known as DDL. For example, create the table, alter the table, drop the table or drop the database, truncate table, rename table. So these things where we are directly dealing with the table or dealing with the database, they are known as data definition language. Fine. And the examples are as shown here: create query, alter query, drop, truncate, rename. All these commands comes under data definition language. But if we talk about data manipulation language, so data manipulation language are the queries or the commands that are used to update or that are used to deal with the data of the database. It is not used to deal the database or the table, but it is actually used to deal with the data that is present inside the database. So which are the queries of data manipulation language? Select query, update, insert, delete. These are the queries that are used to manipulate the data of the database. So they comes under DML. Fine. Then we are having data control language. So the main 2 commands that comes under this data control language are grant and revoke. So whenever we want to grant the access or revoke the access of any user from the data, we can use this data control language. That means we are giving the control that who can access my data and who cannot. Fine. Then we are having transaction control language, TCL. So the commands like commit, rollback, save point, these commands that are actually used for managing the transactions in the database, they comes under this transaction control language. Fine. So as we know, these are what? These are commit means I want to commit or save whatever I have done, all the queries that I have done till now in the transaction. Rollback means I want to roll back my transaction. Rollback means you can understand it like undo kind of thing. Fine. So whenever we want to deal with the transactions, these queries will come under transaction control language. So overall, it implies the queries that are used for update, modify and manipulate the data. So these are all about database languages. This is also one of the important questions that are being repeatedly asked in the interviews. Fine. Then we are having, what is the purpose of normalization in database? So again, normalization is very important in database. It is an important concept. Normalization is a process of analyzing the given relation schemas according to their functional dependencies. It is used to minimize the redundancy and also used to minimize insertion, deletion and update distractions. So normalization is considered as an important process as it is used to avoid the data redundancy, insertion anomaly and updation anomaly and deletion anomaly. Fine. So this is the purpose of normalization in DBMS, and mainly the questions can be asked out of these. So most commonly used normalization forms are first normal form, second normal form, third normal form and BCNF, that is Boyce-Codd normal form. Now in these four normal forms, they can ask you different types of, see, this is the important question that is being asked, that what is normalization? Now, if you can answer this question, then obviously as the interviewers do, they can deep dive into this topic and they can go on asking about the particular normal forms. So obviously we cannot detail the whole concept here because this is a very big concept. So I would recommend you to go through all the normal forms, how they are different from each other, some of the examples. Fine, because they can give you pen and paper also to ask these type of normal forms. So these normal forms are very important to know and they are frequently asked in interviews. So normalization is an important concept that you should know about in very detail. Fine. Okay. Let's see next question. Differentiate union all, operator and union. So how union and union all are different from each other? So the combined records of two tables is written by union all operator and the distinct records of two tables is written by union. So union means what? See, union all, whenever you say only union, you can take it as the normal union operation that we are doing in maths also. So for example, I am having two set, one is containing 1 2 3 and the another set is containing 3 4 5. So when I am doing union of these two sets, one is containing, see again, one is containing 1 2 3, the second one is containing 3 4 5. Now whenever I am doing union of these two sets, what I will get 1 2 3 4 5. So 3 is repeated in both the sets, but when I am doing union of these two, I will not get 3 two times, I will get it only once. So what happens in normal union operation, that redundancies are removed. So whenever I am doing union of two tables, I will get the merged or the combined records of both the tables but uniquely. Fine. But if we use union all instead of union, in union all what it will do, it will give the records of both the tables without removing any redundancy. So if I do union all of these two sets 1 2 3 and 3 4 5, what I will get? I will get 1 2 3 3 4 5. Got it? So this is the basic difference between union and union all. Now define aggregate functions. This is also important, that what are aggregate functions? Aggregate functions are the functions which operate against the collection of values and returning single value. Fine. So what are aggregate functions? In aggregate functions, the input is always multiple values or collection of values. It does some operation on those values and it gives us a single output as a result. So which you can say are the examples of aggregate functions, like sum, minimum, maximum, average. These are aggregate functions. Because what they do, for example, sum, what it will do, if you give 10 numbers to this function, it will find out the sum or the addition of these 10 numbers and it will give you one single number. If you find out the minimum of, if you want to find out the minimum of these 10 numbers, you will give these 10 numbers as input and the min and max function can give you one single minimum number out of them or one single maximum number out of them. Similarly, in average, all these 10 numbers can be given as input, and as output, it can find out the average of those 10 numbers, that is the sum of those 10 numbers divided by 10. So it will find out the average and it will give us the single average result as the output. So such functions are known as aggregate functions. And then define join and enlist its types. So what is join? Join is basically helping us in explaining the relation between different tables. They also enable you to select data with relation to data in another table. So what is join used for? In simple words, you can remember it like whenever you want to retrieve the data from multiple tables. I am having 2 tables or 3 tables and I want to deal with the data of all the 3 tables together. In such cases, we can use the join query. Now there are different types of join like inner join, outer join, cross join, natural join, equi-join, non-equi-join. So again, as I told in normalization, this join is also one very wide topic, very important topic. Like again, if I want to explain you join only for this topic, I do need a great amount of time. We cannot discuss the whole topic here, but again, just I want to let you know that this is very important topic. They can ask you what is join, and also they can ask you about any type of join in particular. They can give you pen and paper and ask questions about them. So I would recommend you that go through this whole topic once. See, again, in this question, my aim is to let you know what are the important concepts or what are the important questions regarding DBMs that are being asked. Now, in case you want detailed explanation of any topic, like if you want detailed explanation on join, or if you want detailed explanation on normalization, if there is any topic for which you want detailed explanation, you please let us know in the comment section, so we can provide a separate tutorial or separate video for that topic for you. We can always do that. So please let us know in the comment section if you want anything like that. Okay. Now what are super, primary, candidate and foreign keys? So these 4 are also important, that what are super key, what are primary key, what are candidate key and what are foreign keys. So super key is the set of attributes of the relation schema upon which all the attributes of the schema are functionally dependent. No 2 rows can have the same value of the super key attributes. So what do we mean by super key? So we are having one table, and in the table, if you are having a set of attributes that can uniquely define our rows, we can say that it is our super key. And candidate key, you can say that candidate key is the minimal super key. See, for example, let's say I am having one table of student. So we know that the student ID, or let's say the enrollment ID, is always unique. So enrollment ID alone, this field of enrollment ID can define all your rows uniquely. So we can say that enrollment ID or enrollment number is my candidate key. Fine. Now if I join any another column with this enrollment ID, for example, if I together take enrollment ID with the student name, then this can become my super key, because this is the superset of this enrollment ID, and they both together can also define any row uniquely. So in that case, like you can understand the difference like this. Candidate key is the minimal super key. So enrollment ID alone is capable of defining the rows uniquely. So candidate key, you can say that what is candidate key in this case? Enrollment ID. But if with enrollment ID I take student name together, we can say that these 2 together can make a super key. Fine. Okay. Now what is primary key? Primary key is also one of the candidate keys. One of the candidate keys is selected as most important and it becomes the primary key. We all know that primary key is very important in case of any table. Primary key, there are some of the constraints that there cannot be more than one primary key in any table. It should be only one. Primary key should always be unique. In primary key, null is not allowed. So yes, these are some of the constraints regarding primary key, and it is most important in any table that can define any row of the table uniquely. Fine. Now what is foreign key? Foreign key is actually altogether a different, it is of different importance. So foreign key is a field or collection of fields in one table that uniquely identifies a row of another table. So you can understand it like, for example, I am having a student table. In the student table, I am having the details like student enrollment ID, student name, student address. Fine. Now, for example, at the time of result, I am making one more table for student result. So in the student result, student ID, student enrollment ID must be there. So in the student table, student enrollment ID is the primary key, but in the result table, student enrollment number is the foreign key that will be referencing to the primary key, the primary student enrollment ID in the student table. Fine. So this is how the primary key of one table and the primary key of another table are related to each other, and the main one is known as the primary key, and the second one in the second table, that is the result table, in that primary key is known as the foreign key, that is actually referencing to the primary key of this table. Fine, I hope it is making sense. Now, what is the difference between primary key and unique constraint? So, what is the difference between them? In the primary key, null is not allowed. The unique constraints can have null values. So, the very first thing is, in primary key, null is not allowed, but in the unique constraint, null is allowed. There is only one primary key in the table, but there can be multiple unique constraints. So actually, like any field in your table you will be having multiple fields. So any field in your table, you can declare it as primary key, or you can declare any field as the unique constraint. So in your table, there can be only one primary key, but there can be multiple unique constraints. Like only one field can be your primary key, but there can be multiple fields in your table that are unique. Right? What is the difference between trigger and store procedure? So trigger is a code that is associated with insert, update or delete operations. The code is executed automatically whenever the associated query is executed on the table. Triggers can be useful to maintain integrity in database. So trigger, you can define it something like, whenever I insert something on this table, I want this thing to happen. So it is triggered. That means whenever any event is occurring, based on that event, you want to make something else done. So in that case, you can make trigger for such purposes. Fine. Now, what is stored procedure? A stored procedure is like a function that contains a set of operations compiled together. It contains a set of operations that are commonly used in an application to do some database task. So stored procedure means you can consider it as any function or method. We are normally in any programming language, you know that we are making functions or we are making methods for any purpose, for any specific purpose. In the same way, in the stored procedure, what we can do, so for example, there is a result table. So I want a stored procedure where whenever I am providing the marks of different subjects, it will automatically calculate the percentage. Fine. So in such cases, stored procedure can be made. So what will happen, that once you are making that stored procedure, you can use that for every student, and for every student you will provide only the marks of the subjects, and it will automatically return you the percentage after calculating it with the help of the code that is written inside of a stored procedure. Fine. So these are the main two differences between trigger and stored procedure. What is a transaction? What are ACID properties? So this is a simple question, but it can be asked. Database transaction is a set of database operations that must be treated as whole, means either all the operations are executed or none of them are executed. So actually transaction are the set of operations that we want to do. Fine, the set of operations, and they should always be taking place in the sequence that is desired. And in the transaction, we want that if there are, let's say, 10 operations, so either all the 10 operations will be executed or none of them will be executed. So these are some of the constraints that we want to apply on our transaction. And ACID property, this is the set of properties that guarantee the database transactions are processed reliably. So ACID property is very important for any transaction in the database. And ACID means atomicity, ACID, they stand for atomicity, consistency, isolation and durability. So again, yes, this ACID property is very important concept of DBMS that is very frequently asked. Then what are indexes? So you must have heard the name of indexes. So what are indexes or why are they needed? A database index is a data structure that improves the speed of data retrieval operations on the database table. So what happens? What is index? So we are having bulk of data in our database. let's say we are having 10 rows, 100 rows, whatever are there. Now for all the rows or for all the record of our database, automatically one unique number is attached to it, that is known as index, so that whenever we want to retrieve the data, it can become very easy and it can be done very speedily. So indexes are mostly needed for that. You can say that the main advantage of the index is that it allows faster search according to different frequently searched values. And so our retrieval can be done very quickly, the search processes can be done very quickly. So indexes are very important for the data. It is especially beneficial whenever the number of records in our database is very high. So whenever we are having many records in our database, in that case, normal retrieval or the normal search procedure can be slow, but with the help of indexes, it makes those procedures very fast. Now define a relational schema. So what is relational schema? A relational schema is specified as a set of attributes. It is also known as table schema. It defines the name of the table is, what is the name of the table, you can say that relational schema is nothing but it is the blueprint of our database. Like if I give you quickly small example, so see what happens that whenever any building is built by the builders, so it is not happening that directly they are putting the bricks, putting the cement and they are starting the construction. Fine, things don't work like that. So before actually building any such building, what is needs to be done? So first of all, one layout is being made. So what is the actual area, how many rooms they want to make, or what are the number of floors that they want to make. So first of all, one layout is built, one layout is designed, and after a proper layout, then and only then the implementation can be done. So similarly, whenever we want to make any table or any database, we want to design any database, so before that, making the relational schema is very important. So you can say that you can give such examples and you can relate it with that it can be told as, it can be depicted like it will be a model or it will be the blueprint of the actual database that will be created later on. So relational schema is actually very important, that will contain our set of attributes, our table name, our table structure, everything will be defined in this. Fine. Okay. So then what is the ER model? So we all must have heard about ER model. So what is ER model and why it is important? ER model stands for Entity Relationship Model. So again, this is also model. So as I gave example in the previous question, so in ER model also, before going to actually build our table, we are first of all making the model that is known as entity relationship model. In this, we are just depicting that which are the different entities that will be present in my table. Different entities like student will be one entity, faculties will be another entity. So which are the entities which will be present in my tables, and in that entity what will be the relation between them. Like there can be different relationships like one to many, many to one, one to one. So in this we are just depicting and in ER model we are mainly depicting with the help of ER diagrams. Fine. So in ER diagram, as you can see here, we are having different representations, like entities are represented by rectangles, relationships are represented by diamonds, attributes are represented by ellipse or oval shape. Similarly, we are having different designs, we are having different we are having different things to depict different things in ER diagram. So with the help of those symbols, we are making the entities and we are clearing out the relationship between them, so that after that whenever we are directly making the table, it will be very easy for us. So this is the model that we are making before the actual implementation. What is a relationship? So as we have seen here, relationship means how my different entities or different tables will be related with each other or will be associated with each other. So there are mainly three different types of relationships that we are defining in DBMS. That is one to one, one to many, many to one, or many to many. Fine. So one to one means one entity of like one record of this entity will be directly related with one record of this entity, like that. So as the name itself indicates, one to one, one to many, many to one. For example, one student will be related with many subjects. So that will be one to many. So similar kind of thing. One teacher or one faculty will be related with many students. So again, this is one to many. So in this case, like logically also you can think that how the entities will be related to each other, and based on that, such kinds of relationships can be established. Then at last, this is again one important question, that what do you understand by query optimization? That what is query optimization and why is it needed? So basically we can say that this query optimization is done to reduce the time complexity, to reduce the space complexity, to make our query execution fast. So these are some of the important benefits of query optimization. And if we just say that what is query optimization, so we can say that how it came into the existence. So the concept of query optimization came into the existence when there were a number of methods and algorithms existed for the same task. Then the question was that which one of them is more efficient, and the process of determining the efficient way is known as query optimization. So for example, we are having 2 or 3 different ways to write query for the same problem, but in that case we have to determine that which query is the most optimized one, which query is the most efficient one, and then we will go with that particular query. So query optimization means reducing the complexity of the query, reducing the length of the query. Anyhow, the aim of the query optimization is to decrease the time complexity, space complexity, and to make the query execution fast. Fine. So these are some of the important concepts of DBMS that can be asked in the interviews. I hope you have got an overview idea. I hope now you would be able to crack your interviews, specifically the DBMS part, very well. So that's all for today. Thank you so much.